Okay, let's get started. My name is Stefan Hajnoczi. I work for the virtualization team at Red Hat. Today I'm going to be talking about virtio-vsock, and it's a new host-guest communication mechanism for KVM, but for virtio, so potentially anyone can use it. I'm going to be covering the use cases of host-guest communication just to kind of explain, what is running over host-guest communication, what's it good for. Then I'm going to give an overview of virtio-serial, which is what we use today. And then I'll kind of describe the features that are missing and the limitations that we have, why we want to create a new mechanism for host-guest communication, and what the advantages would be. Then I'll cover some of the details of how the virtio-vsock device works. And then finally, I'll also touch on how to port existing programs to use virtio-vsock. And finally, I'll give an overview of the patches, the status, where we're at right now with the development. Okay, so the host-guest communication use cases. Let's get started, try to talk about why do we want host-guest communication? There are usually kind of two models. Either there's the guest agent model, where there is a program running inside the guest that is a server, and it responds to commands coming from the host. There are some examples of this. There's the QEMU Guest Agent. It's part of the QEMU source tree. There's also the Spice VD agent. And basically what they do is they perform features that hardware doesn't do. So normally QEMU emulates graphics cards, mouse, all those kinds of things. But there's some extra features in virtualization that we have that the hardware doesn't support. So there's nothing we can emulate. There are no hardware registers. There's no functionality there in the hardware. So one way of making this functionality available is to introduce a new communications channel between the virtual machine and the hypervisor. So one example, an easy-to-understand example of this, is clipboard sharing. So Spice VD agent is used for this. If you're running a virtual machine and you can see the desktop and the window's open, if you want to copy-paste some text from outside, some text from your host, into the virtual machine on the remote display, the Spice VD agent can do it. What it does is, on the host, it takes what's in your clipboard, so some text that you copy-pasted. It sends that through the host-guest communications channel into the guest, and the agent will then see that command, and it will use the APIs inside the guest operating system to perform the paste. Some other use cases, for example, the QEMU Guest Agent supports application-specific backup. Application-consistent backup. So what that means is that the hypervisor is able to send a message into the guest before a snapshot is taken for backup. That way, the application's databases or anything really can quiesce and can flush out the data and write it to disk. So everything is on disk before you take the snapshot. If you don't do that, what could happen is there could still be state in RAM that is not written to disk. So even though you took a snapshot at this point in time, your disk image doesn't actually contain the data. So that's why application-consistent backup is useful. It's another use case for host-guest communication. Some people want to write custom agents because they have big deployments. They've got hundreds or thousands of VMs. They need to do custom. They want to automate custom communication functionality. So that's another scenario for writing something specific to your application or to your deployment of virtualization. Okay, so that's agents. The other use for host-guest communication is host services. We can do it the other way around, and instead of having a server inside the guest that is responding to commands, you can have a server on the host. You can do things like file sharing, for example, sharing a directory from the host, making it available inside the guest. So that's another kind of That's another use case for HostGuest communication. By the way, if you have any questions, feel free to interrupt me as I go along. Okay, so let's look at what there is today. virtio-serial is the device that is used today for HostGuest communication. The SPICE VD agent that I mentioned and the QEMU Guest Agent that I mentioned, they both can use this. The model that the virtio-serial device gives is serial ports. That's the kind of abstraction that it presents. And on the host, ports can be added and removed. The guest cannot dynamically create new ports, so it's not quite like sockets, like TCP sockets, where you could just launch a program, it would create a socket. Instead, ahead of time, you have to kind of decide how many virtio-serial ports you're going to have at maximum, and then you can enable them and use them at runtime whenever you want. Good thing is the ports can be named, not just numbers. They have an actual human-readable string. So QEMU uses a reverse domain name. We use org.qemu.guestagent for the guest agent. And the way that appears inside the guest is that in /dev, there is a virtio ports directory, and you can see all these virtio-serial ports by name in there. So you could just open dev virtio ports org QEMU guest agent. By the way, those are character devices. So if you do an ls in the directory, you'll see the character device nodes because there is a driver, a guest driver in the kernel that is a character device. So on the host side, how does an application talk to an agent in the guest? Well, basically QEMU's chardev subsystem allows you to connect. You kind of tunnel through QEMU. The client app can connect with a Unix domain socket, for example, send a message. QEMU takes that, injects it into the virtio device, and then the virtio device receives it inside the guest, and that's where the guest agent will then read the message and process it. Okay. So what are some of the limitations of this model? The first thing is that a serial port is a bidirectional communications channel. But it's not like, for example, with TCP/IP, where you can have a web server listening on port 80, and the client connects, starts transferring data. In the meantime, another client connects. They have their own conversation, and more clients. You can have lots of clients and sessions running at the same time. Because this is a serial port, there's only a one-to-one conversation going on. So you can't really have this model of n-to-1 connections connected at the same time. And the implication of that is that, if we go back to this diagram, if maybe the guest agent provides a service that's useful to more than just one client on the host, and you want to have multiple processes connecting at the same time, then you need to do extra work to arbitrate access to this channel, because there's only a single port you're using, or you have to allocate more virtio-serial ports. So it's not very flexible. So, for example, libvirt arbitrates access to the QEMU Guest Agent. If you want to send a QEMU Guest Agent command, you first have to ask libvirt, and it will only send one command at a time. So that's a little bit clumsy, and depending on what type of guest agent you want to develop, that's just a little bit of a pain. The other thing is that the serial ports only provide stream semantics. For some types of communications protocol, you want to use datagram semantics, so you actually have message boundaries. You have a message, it can have 0 or more bytes. And if you don't have that, if you only have stream semantics like a serial port, it just means you need to add another layer of framing on top, a little header. So basically, applications that are not suited to stream semantics, they're a little bit uglier, require a bit of extra work as well. But the real reason, which I put at the end here, is what I mentioned before about character devices. In this model, the virtio-serial model that I'm showing you, inside the guest, these serial ports are actually just character devices. And what we're all used to using and what most programs support is the sockets API for TCP/IP. So if you have existing code you would want to do, like say you have a little REST HTTP server, it's not just going to run. on virtio-serial because you have this impedance mismatch. You've got a character device, but your code wants to use sockets. They don't go together. So it would be really nice to be able to do guest communication with a proper sockets API, because then we could take all the existing code and libraries and just reuse them if you want to communicate between host and guest. So socket syscalls would be great. So what it comes down to, all these limitations I've been telling you, I've always been kind of referencing TCP/IP and networking. So the first obvious solution is to say, well, maybe we could move to having dedicated NICs in the guests for host-guest communication. And the cool thing about that is that the support for TCP/IP and the stacks are obviously available in all the guest OSs already. No new code needs to be written. But the problem with this is that you can set it up manually, but if you try to automate it, for example, if you want libvirt to do this and go inside the guest, bring up a network interface and configure it, assign an IP address, there's actually more things you need to do. Firewall rules, interface naming, all of this becomes very invasive. If you think about the fact that our guest might be Windows and all the different flavors of Linux, it's actually really hard for libvirt to automate this, or for anyone to automate this, adding a new interface into a guest without disturbing the guest. If you're in a cloud environment, for example, the admins of the VMs might not really understand all the details and know about how your platform works. And if you still want to use host-guest communication in there, for example, you still want to run the QEMU Guest Agent, and you use a network interface, then the administrator might use a strict firewall rule, and that will actually block connectivity accidentally because they don't know about this. So it's very fragile. And this is kind of the problem with Ethernet. And when I was investigating this, I also noticed that none of the other virtualization solutions, Xen, VirtualBox, they don't use a dedicated Ethernet NIC either. And I think it's these same problems that we see here. You could set it up for yourself, but to automate it is hard. So we really want something that's zero configuration, something that's not going to be broken accidentally by the guest. Okay. So let's move on to vsock. So AF-vsock is a address family, a socket address family that was added to Linux in 2019. So it was added to 2013, not in the future yet. So it was added, and it was contributed by VMware because they already have this mechanism, and they wanted to upstream their code. And when they were upstreaming their code, some people from the KVM and Linux community, Gert Hoffmann, who was here, participated in that reviewing and said, okay, if you're going to add this to the Linux kernel, let's make an abstraction. Let's make it possible for other hypervisors to also add their own transports to this. Let's make virtio possible. So he actually started working on virtio transport, and later on, Asias Hay also took over that, started developing that code, and that's what I'm working from now. I've taken it over, and I'm working it, and obviously my goal is to upstream it. And basically, just to really briefly describe how vsock works, is that vsock gives you stream sockets, and it also gives you datagram sockets. So the equivalent of that would be TCP and UDP. The only thing that's different is that the addressing scheme doesn't use an IP address. It just uses a 32-bit CID, just an ID, a unique number. The port number is 32 bits. And the way it works is that the host has a well-known CID, so a guest always knows how to talk to the host. And each guest is assigned a unique CID when the virtio vsock device is added. So when the guest boots up, it knows its ID. So there's no DHCP, there's no configuration required. It's just there, and it just works. Okay, and now I'm going to start going into the actual architecture of how this works. So the way this is implemented is this new virtio device is not emulated for the most part in QEMU. This is a vhost device. So similar to vhostnet, where packet processing for networking happens in the kernel, in the host. It's the same story here. So the module is actually called vhost-vsock. And QEMU has very little code. QEMU just sets up the device, and then hands over the vert queues and the vring to the vsock module. And the reason for this is that in the host kernel, the vsock module is able to talk to the network stack, and therefore your sockets, your programs can just open AF vsock sockets, and their data basically is transferred through the host kernel's network stack and then into the virtio device, and then the guest sees it. If we tried to emulate the vsock device in QEMU, then we'd have the problem that we don't have privileged access to the network stack. We can't add a new address family. You have to be in the kernel. Only kernel code can do that. Okay, so and then inside the guest, there is just a guest driver, the virtio transport. And that connects to the vsock code, and both the guest agent in this diagram and the client app on the host, they just use socket syscalls. So if they want to talk to each other, they can just create a socket. One of them listens, the other one connects. Okay. So how does this virtio device work? It has a receive and a transmit queue, very similar to a network card. It has a control queue. Actually, the control queue is kind of for future use. There are no commands on it right now. But the properties of the receive and transmit queues are that you send, obviously, the data payload that you're transferring into the guest and out of the guest, but there's also a small virtio-vsock header. And that header allows connection establishment, shutting down connections. So a few of these socket lifecycle messages need to be encoded in there. One of the interesting things with the design is how do we make sure that the stream sockets are reliable? Because the semantics for sock stream sockets is that they are reliable in-order delivery. So what happens is that on both sides, in the guest and the host, they both announce how much buffer space they have available. So that's the credit-based flow control mechanism. Basically, because both sides know how much buffer space is available for receiving more data, before you send, you need to check that the other side still has enough buffer space available for this message. If you were to exceed that, then your data might get dropped. So any well-behaved implementation will not exceed it. Then at that point, you'll block. You'll wait until the application, that it needs to wait before sending more data. That's how the stream semantics are implemented. For the datagram semantics, it's best effort. It's unreliable delivery. So there, we don't need the credit-based flow control. And the final thing that you see here is I talked about auto-configuration, how each guest automatically knows this is my CID, so this is my address. Well, that's just in a configuration space field in the virtio device. So the device, when the driver starts up, the driver immediately says, here's your address. It's kind of similar to when you have a network card and it reads the MAC address off the EEPROM. It's the same kind of thing. Okay. I won't go into a lot of detail in this, but basically the way that the stream protocol works is that it's kind of a stripped-down TCP. It's kind of inspired by TCP. So this example just shows you the state transitions of the sockets when you have a server that's listening and a client that sends a connect request. There is this kind of three-way handshake, and after that, both sockets are connected. And at that point, they can just transfer data. And then it does have this half-close kind of feature as well, where you can say, I'm shutting down the socket. I'm not going to send any more data, but I'm still willing to receive. It's kind of just the network stack supports it, and TCP also has it, so why not? So it's also available in virtio-vsock. Okay, so porting code to vsock. So if you have a program, so if we take just any little network program, like netcat, for example. Netcat knows how to speak IPv4, knows how to speak IPv6. It can do UDP and TCP. So it would be nice to add vsock support to it as well, so that you could use the netcat utility to talk to your VM or from the VM to the host. What code changes are necessary? What do we need to do to netcat to make it work with vsock? Well, if you want to create a vsock socket, instead of using AF-INET when creating the socket, you use AF-vsock. And then the other thing is that the sock adder structure for specifying the address and the connection details is a little different. Instead of an IP address, we have the CID field. For the most part, that's it. Some applications don't create a raw sock adder. They use libc APIs like getAdderInfo, where libc will actually parse the string, can do DNS resolution, and then at the end it gives you your sock adder. That part is missing. I haven't implemented that yet, but I think it will be necessary to probably extend that so that programs that use getAdderInfo can work with vsock as well. But once you've done this, once you've created and connected, you can just use socket system calls. So after that, all your code is shared. You don't need to, when porting programs. It's kind of similar to adding IPv6 support to an existing program. It's not that difficult. Okay, here's kind of the chart of the overview of the patches. None of the boxes is green yet because nothing has been merged yet. And that's my fault because I have sent out the yellow ones. So the most important ones are the specification, the virtio specification. That obviously needs to be accepted by the community because this is a new virtio device that we're designing. So I've already gotten some feedback on that, and I need to just iterate and improve the feedback on the feedback and keep resubmitting. There are the guest and the host drivers, which I've also sent out on the mailing lists. And the QEMU code is very small. All we need to do is create the virtio device and then start vhost, the kernel module. So I haven't sent it out yet. First, I want to make sure that the specification is accepted. It would be nice to extend getAdderInfo. I mentioned that before, but I haven't done that yet. Now, finally, I don't have time to go into this, but really what my aim with this is I want to do folder sharing or directory sharing between a guest and a host. And I don't want to use 9p. So I have NFS client running over vsock. And this is kind of the cool thing about it, is that once you have a socket, all the NFS code can use it. And you don't have to reinvent or rewrite a file server. You can just use all the existing code. So the NFS server patches are not yet ready. I haven't implemented that, but the client is working. And right now I just tunnel it onto a TCP NFS. So I've got TCP NFS talking to vsock NFS. But yeah, so those are my next steps. So here, go ahead.
Out of curiosity, why don't you like 9p?
Yeah, so there are a lot of reasons for that. So one of the most basic reasons is that in 9p, in QEMU, you have two choices. Either you can use the 9p backend that is built into QEMU to do your actual file I/O, or you can use the virtfs proxy, which is a separate process. And of course, the proxy is a really good idea because that way we can get privilege separation. Because you don't want QEMU to have FSID, FSUID root or whatever, so it can write files as any user. So from the security model, you need to use that. But unfortunately, the virtfs proxy is incomplete. It doesn't actually support the same features that the built-in code in QEMU has. So development stopped a few years ago. And I think no progress is being made. I think there's some other issues with it. So I think that really what we should be doing is we shouldn't be reinventing a file server inside QEMU. We should just be using a mature file server and protocol that already exists and works well. So what we're doing here is we're just adding a network transport instead of reinventing that whole stack. And that whole stack doesn't work that well today. The 9p stuff is fine if you're running QEMU from the command line. But if you have it in like a real production deployment with SE Linux and libvirt managing it and stuff, it's not there. And since there's no community behind it, and I'm not really happy with the quality of the code that's in QEMU either. I don't think it's it's not really what I would focus on. So Windows support is a good question, and we don't have a prototype that works yet. There are kind of two ways to do Windows support. One way is to do it just like virtio 9p. Someone's got to go and write a Windows driver that speaks 9p. Well, you could do the exact same thing for NFS, except for sending the 9p commands. You're just sending NFS equivalent commands. The other way would be to do something fancier, where you reuse Windows file sharing and you use Samba on the host. QEMU already has a little bit of a tie with Samba anyway, since we have a command line option to launch Samba. But the problem there is, how do you get Microsoft Samba code to speak vsock? And I don't think we figured that out. So maybe it's easier to just write the whole driver the way we would do for virtio 9p. You know, it's the same kind of thing, except the actual network protocol is a bit different. Can you use the mic? I didn't hear you, sorry.
The question is actually exactly what I was intended to ask. What is about Windows? You see, in Linux there is no problem. But what is about Windows guest, BSD guest, and another guest?
Yeah. Well, so first of all, I guess you have the same questions for virtio-serial, right? So there are drivers, there are open source drivers for Windows. I think the FreeBSD virtio drivers are kind of a volunteer effort where there's no actual. I'm not sure if there's any dedicated development effort behind it. Yes. Well, I mean, I have to admit, I don't know the Windows driver, development details and how to hook in. I did look briefly, and I looked and I saw that at least there's something called Sockets Direct in Windows. I'm not sure if it's available for all versions, and what it seems to do is it seems to take TCP/IP and allow you to plug in your own custom protocol. So in that case, that would be virtio-vsock. And I was hoping that maybe the Windows file sharing can then speak over vsock. But I haven't prototyped. I don't know if it works.
So I've got a question. We're very keen to use this with libguestfs, but what's the performance like compared to virtio-serial?
Okay, so I think that virtio-serial, I didn't mention performance here. That's because I'm not actually expecting there to be a big performance difference. I think that virtio-serial performance is probably not that bad. And Amit is here, and I think we had a contribution a few years ago to implement splice for virtio-serial. So it should be the same. Virtio-serial is not slow. That's not the problem with it.
So I think this is not your design decision, it was VMware's. Why doesn't it just reuse TCP and UDP over some level 3 abstraction?
Yeah. So I guess that's another question. So if we implement stream semantics and datagram semantics, I'll show it on the slide, and we're doing this kind of stuff. We're basically just doing a stripped down TCP. Why are we not using TCP? And there, I think this is really just, it's not that much harder. All the fancy stuff in TCP is to deal with unreliable networks, right? And the kind of performance scaling and all those issues that you don't have when you have a vRing and you're on the same host. So I guess that's why it wasn't necessary, because there's not really that much good stuff we can get by reusing it. And it's pretty simple code.
Okay. So what I get is you're starting on the host a respective agent, right, who can open up a port. What I'm not sure is, how are you doing the policy stuff? So how do you identify which guest connects to which application on the host and so on?
Yeah, okay. So that's a good question. Basically, I guess the question is, when you have vsock, who gets to talk to whom? Are there any firewalls or any policies? And there's no IP tables or anything like that for it. So it's basically just very simple. Just like any sockets program, when you bind the socket, of course you can, you bind to the host interface, but when you accept the socket, you see who your peer is. You do not have to talk to someone you don't want to talk to. It's very simple at the moment.
Yeah, but what you see is just a number, right? You see just the CID.
Yes.
And you don't have any matching to any name or any configuration to actual process.
Okay, yeah, absolutely. So I think at the moment the simplest answer is just that the CID information, so you know who you want to be talking to, would need to be given when you start the service, or it has to be from the management stack is where it has to come from. We can talk about it later if you have a more complicated example where it doesn't work.
Actually, I do. That's exactly what my question was about. Basically, what do you do in a system? Hey, you should get closer. Do you hear me better now? All right, awesome.
Alex, can you move a little bit closer to the mic?
Even closer this way? Better?
Yes, now.
All right, awesome. My main concern is what if you have a system that is multi-tenant? If your host is not just a random simple libvirt setup, which is always running as root on this thing and is actually pretty stupid from the multi-tenant view, but instead is an actual, even if you wanted to use libvirt, just assume that you're using multiple containers on the host to contain your different virtual machines. How do you separate those out properly, and how do you do migration?
Okay, so there are a couple of questions there. How does live migration work? I think the simple answer for that is the connections are terminated on live migration. I haven't implemented this yet. Live migration does not work yet, but I think that the first step is to just terminate the connection and expect a reconnect, because it's hard to migrate the state. It basically means that any client and agent both also need to support live migration. So I think it's simpler to just kill the connections and have it restart when it migrates. I think the other question you had was about basically namespaces. How do you separate things out? And one of the limitations of the current patches is that it uses global variables. It does not support network namespaces. So maybe we should actually think about that.
Even if it's not namespaces, say you have a host that, I assume anybody can open a vSock host socket, right? So assume there's a big server where somebody just happens to get user access by random means of whatever. It could be an exploit. And he just opens up a server on a port that would open you an NFS server or, say, a Samba server Windows, which that Windows machine would then connect to. You can use up the next bug, and off you go. You're in. That's really not something you want to be. I mean, you do not want to expose random applications on the host to the guest. You want to really make sure that you only have a certain set of those that you do have, which is one of the really nice things about virtio-serial. Because virtio-serial does only allow you to connect to processes that you as the QEMU starting process, the person who started QEMU, dedicated them to, right? So there really needs to be some broker, I would say, in between that just, and at that point you don't even have to use vSock on the host at all anymore. You could just have a broker, say in QEMU, that just has a map and says, for this vSock connection X, just go to TCP connection Y, call it a day. Then you don't have to care about anything on the host at all anymore. It would just be normal TCP IP connections for that one. You could even do it over the network if you really have to. And you only have vSock for the guest.
Yeah, so I guess the point, it's a good point, and it's really not solved right now, is that ideally you really only want to expose a certain set of ports to a certain guest, and they shouldn't see all the ports. On the other hand, we have the CID namespace. So there's probably scope to just bind to one CID and not have the other CID. Do you understand? To basically assign a unique CID for every guest host pair. That's like your namespace, your visibility.
That still doesn't get you. Okay, so say user A and user B want to start something. How would they know that they? I mean, I bind to the host port 1, 2, 3, 4. You would want to bind to the combination of CID1 and host
right.
port 1, 2, 3, 4.
Yeah.
How
So
do
with
you
the
know
sockets,
that it's that port in advance?
Yeah. So, I mean, I'm not going to be able to come up with a solution on the spot, but yeah, that's definitely something that we still need to solve.
Honestly, mapping it to IP is probably the smartest move.
I'm sorry, I didn't understand.
Mapping it to an IP-based network protocol is probably the smartest move because that way you don't have to modify anything. It just goes and works, and you can have the map even be adjustable on the fly, and you can migrate the map as well, which is good.
So the problem you have with that, the problem is basically all this stuff. Where did I have it? The problems with networking. So basically at that point, what you're basically asking for is you want like a flag on a network interface in Linux or wherever saying this is a hidden interface. The user shouldn't be able to see and mess with it too much.
No. I do not want anything in the guest. The guest should still use vsock. That's the way you envision it.
Yes.
The host, you would not do a vhost vsock. You would instead do it in QEMU, and QEMU would just do normal BSD calls.
Yeah. So that's an interesting idea, and we should talk about it more. But what I don't understand is if the guest is doing vsock, then how do you handle addressing? How do you map it all to IP on the host? So it's non-trivial, but it's interesting.
You have the map in QEMU. You have a map in QEMU that says if the guest, and you don't care about CIDs at all anymore at that point, if the guest just goes and connects to port 1, 2, 3, 4, that means instead you connect to TCP connection there, 1, 2, 3, 4. Done.
Yeah, let's talk about it more. I mean, one of the things that throws away is the performance advantages, for example.
Shouldn't be too bad.
Yeah. I mean, we have to try it out.
You can still do vhost if you have to.
Yeah.
What? Yeah. I mean, we are doing BSD calls all day long, all the time in Linux. It shouldn't really be too bad.
Yeah. Okay, thank you.
Hello. Yes, because you're using the host kernel's networking stack, I was a little hazy on how that connection worked. Does this mean you rely on having the guest running under KVM, or is this something that's also available to TCG guests?
So right now, vhost only works with KVM. It doesn't work with TCG. And there's a couple of reasons why. The IO-event-FD and the IRQ-FD stuff is not hooked up for TCG. I was playing around with it a little bit. I had a little patch. I think I showed it to Paulo, like a little patch to emulate IO-event-FD. I sent it out to the mailing list, actually. So there's still some work necessary. I think I found some other problems. It won't work with TCG out of the box.
But there's nothing fundamental that stops TCG from hooking in or emulating the bits it needs. And
I think more patches would be necessary to get it working, but it can probably be done, yes.
Okay, thanks.
Could you please skip to the status slide? So one box that I'm missing here is the box for AF-vsock. Would that be green already, or is that waiting for those implementations to get finalized?
So AF-vsock is in Linux. Right now, if you look in net/vmw/vsock, it's already in Linux. So all I'm adding, actually, to the Linux code is this virtio transport module, and it sits right beside VMware's VMCI module. Yeah, it's just a transport.
And as far as the specification status, does that mean that this would be integrated into like Virtio 1.1 then, or what exactly is that?
Yeah, I guess the next Virtio version.
And for that we need one implementation as proof of concept?
Yes.
Okay, thanks.
Okay, thank you very much.